Okay, let's make a start. Right, so we've been looking at beams, and strictly speaking, a beam should be hinged with a pivot at the end for it not to be flying off in the x directions. We needed to do that, but we never really bothered because all our forces are going straight up or down. So let's start looking at bodies where we might be applying forces. So just imagine a rectangle. Okay. The first thing I'm going to do is hinge it. Okay. This is like a solid bit of square body. So I'm going to put a hinge there, and I'm going to put a pivot here, like that. And I'm going to apply some forces. This is going to be 12 meters long and 6 meters high, and we'll apply 10 newtons here. We'll apply 50 newtons here, and we'll apply 30 newtons here. Okay. So how do I go about solving that? Well, the first thing I need is a different colour pen. So I would replace my hinge and my pivot with reactions. So I'm just going to draw them on my diagram here. So R, I'll call this point A, B, C and D. So this is going to be RAX, RAY, and here we're going to have RDY, okay, because it's pointing upwards. So I've now got a pseudo free body diagram, and I've got all the forces here. So now we can go through our process, sum up forces in the x direction. Okay. So when we sum up, they should equal 0. So we've got 30 going in the x direction. We've got plus RAX going in the x direction, and that's about it. So that equals 0. So RAX equals minus 30. Okay. Next, let's sum up the forces. And I went left to right. Sum up the forces going upwards. And what do we have there? Well, I've got 50 coming downwards, so that'd be minus 50. I've got plus RAY going upwards, and then I've got another 10 coming downwards, and then I've got RDY going upwards. Right. So the thing I want to do there is rearrange it. So we've got the unknowns on the left. So RAY plus RDY equals 60. So there we've got an equation we need to solve. So last thing is we will take moments. Where's the sensible place to take moments? Well, it's actually at the hinge itself. We've got two unknowns there. Take the moments at the hinge, then we'll get rid of the unknowns. So we'll take moments at A, and we'll go clockwise. So take moments here. Now notice this is kind of good. With the 50 here, it's going straight along this axis here. So that is not going to create any moment. It's pointing straight through the pivot. So if it points straight through the pivot that you're taking your moments about, it's not going to create a moment. This one here, this 30 it's going to be a right angle. So it's going to be clockwise. So we've got 30. Distance from here to here is 6. So it's a plus 30 times 6. This one here, okay, it's 10. And it's in this awkward position over in this place here. Can you see that? I can't tell if you can or not. So what I'm going to do is I'm going to imagine this 10 moves down until it hits the x-axis. So it's going to move down its line of action, hits the x-axis, then I'll measure it. So measure this distance from here to here. Well, that's going to be 10. That's going to go clockwise. So we've got plus 10 times 12, and that will be the moment created by that one there. Okay, what about this one here? So this is going to create a moment. It's going to go negative. So minus 12 times r dy equals 0. So let's collect my unknowns on the left, 12 dy, make it positive, and then take my knowns onto the right, make them negative, and that is going to be 300. Okay, so my r dy is going to be 300 divided by 12, and that equals 75 newtons. I should have put newtons there. Okie dokie, so we can go back to equation 1 and substitute that in. Therefore, we can say that RAY plus 25 equals 60. So therefore, we got RAY equals 35 newtons. And I didn't bother to work it out in my solution. Okay, so what we're doing here is we've done a very simple body. We've applied a force at an arbitrary location, but we can still cope with it because we bring that force, we use its force line of action until it hits either the y-axis that we're pivoting around or the x-axis. So I've brought this 10 all the way down there, then I've measured it. And these other ones here, so this 50, you can imagine, well, I'm bringing its line of action down and it goes all the way through the pivot, so that doesn't create a moment. This 30 is already sitting on the y-axis there, so we can measure its distance and work out what the moment is there. Okay, so that's not really a framework problem, but it's like a rigid body problem with forces arbitrarily located in space.